try that again. Good morning, everyone. Welcome back to Tech Days. Hope it's been a good conference for you so far. We saved the best for the last day, so I'm glad you decided to come back for day 3 here. My name is Jeff Procyse, and I'm going to do a session here entitled Beat the Clock Background Tasking in Windows 8. If you're thinking about writing Windows Store apps, or if you're already writing them, this may be one of the most important sessions that you attend all week, because as you're probably well aware, or maybe you're not, if you're not, you should be, Windows 8 with its Windows Store apps enforces a one app at a time model. So a user can apparently have several apps active or running at the same time. But an app that is not in the foreground, a Windows Store app that is not in the foreground, is suspended. It gets 0 CPU time. It is not running if the user can't see it. Generally, the only application that's running, the only Windows Store app that's running, is the one that's front and center on the screen, the one that the user can see. There is one exception to that. If the user snaps the screen, that's when they drag a finger over from the left side and split the screen in two with that little vertical bar. That's called snapping. And snapping is the only way in Windows 8 that you can have 2 Windows Store apps displayed and visible to the user at the same time. And in fact, when the screen is snapped and there are 2 apps visible, both of those apps are running. They're both getting CPU time. But that's really an edge case, especially for the purposes of our discussions this morning. When a Windows Store app is not visible to the user, it is not running. It is getting no CPU time. Now, that would seem to be a problem on the surface, would it not? Because what if you have an app that needs to do something in the background? What if that app wants to check the weather forecast every 20 minutes, say, so it can update a tile over on the start screen? Or maybe that app wants to check with some airlines' computers and find out what the current status of a flight is, so that if a flight is delayed, it can notify the user or something like that. How are you going to accomplish that if the app isn't even running when it's not visible to the user? Well, while it is absolutely true that an app that isn't visible to the user is not running, it's also true that Windows 8 provides a background tasking API that under a fairly limited set of circumstances allows apps that are not currently running to get CPU time in the background. So, in fact, it is possible to build apps that check in with the web service periodically to check for delayed flights or extreme weather conditions or something like that. In fact, there are several different scenarios that the Windows 8 team envisioned that you might want to address in a Windows Store app. And in this background tasking API and in some related APIs, they provide for all of those scenarios. For example, there's a class named Background Downloader in Windows 8, as well as a class named Background Uploader. If your app needs to upload or download large files, say, to SkyDrive or to someplace else, well, you may want to make sure that that download or upload continues to take place, even if the user temporarily switches away from your app, technically suspending all of the threads in it. The Background Downloader and Background Uploader classes, however, can continue to run in the background, basically by allowing the system to keep that upload or download going on behalf of your application when the application isn't running. Now, we're not going to talk much about Background Uploader and Downloader unless I have time at the end. I suspect I won't. What I do want to do is introduce the Background Tasking API, a much more general purpose API for allowing you to write and deploy Windows Store apps that do things in the background, that is, when the app itself isn't running. Before we start looking at code, and we're going to look at quite a lot of code here. In fact, I'm going to attempt to build one application live so you can see all the steps involved in doing background tasking in Windows 8. Let me talk a little bit about the constraints. When you use this background tasking API, you can schedule code to execute in the background even when your application isn't running. But the system places some limitations on this. As you're going to see in a few moments, you cannot execute code in the background more often than every 15 minutes. You can execute code less often than that, but never more often than that. Windows 8 simply does not make that provision, with a very, very few exceptions. In fact, Windows 8 also imposes a quota on the resources that a background task receives. Now, one thing you should know for the purposes of this discussion is that when it comes to background tasks, we lump Windows Store apps into two very broad categories. One category is apps that live on the lock screen, applications that have permission to display data on the lock screen that's displayed when the user's away. Those applications are actually less common than applications that don't use the lock screen. And the other category is applications that don't use the lock screen. The reason I mention that is the resource quota is imposed on you depending on whether you're a lock screen app or a non-lock screen app. A non-lock screen app, for example, cannot receive more than 1 second of CPU time, and that is CPU time, not wall clock time, every 2 hours. So you may schedule your non-lock screen app background task to execute every, say, 20 minutes. But the system is keeping track of how much CPU time you're using. If you use up all of that entire 1 second of CPU time, the first time you get activated, the system will not activate you again for another 2 hours. It is watching to make sure you're not consuming resources unnecessarily on that PC. Now, if you are a lock screen app, you have a little bit more latitude. You get 2 seconds of CPU time every 15 minutes. The reason I want to make a point about this is when you execute code in the background, you don't want to do something where you're just grabbing for all the CPU time you can get. The intent here is to allow you to wake up, do something, do it as quickly and efficiently as possible, and then get back out so that you have additional resource quota remaining the next time the system decides to execute your background task. There's also some limitations imposed on your network utilization when you're a background task. If you're running on AC power, then they don't care. They'll let you use as much bandwidth as you want. But if you're running on battery power, then, and I said DC power here, I should have said battery power. If you're running on battery power, then there are some limits imposed on you. Now, these limits are not hard limits. How much you get actually depends on how much bandwidth is available. But a general rule of thumb is for a lock screen app, you'll probably get about 40 megabytes every hour. For a non-lock screen app, about 7.5 megabytes. That should not be a significant limitation, because remember, the idea in these background tasks is to be light and efficient. It's fine to make a simple call out to a REST web service somewhere, get some data back, but you would not want to attempt to upload or download a 100 megabyte file. There are other APIs that specifically allow you to do that. Now, with that, let's talk about how you implement a background task. It begins in your Windows Store app when you add another project to the solution, one to house the code for your background task. In that separate task, you implement a class that implements an interface named iBackgroundTask. Now, as you're going to see, that's a very simple interface. There's just one method in it which you override. It is that method that the system will execute at intervals or whenever the conditions you specify are true. I'll say more about that in a moment. So the code in that class that implements iBackgroundTask is your code that will execute in the background. By default, it will execute in a separate process called backgroundtaskhost.exe. Remember, your app may not even be running at the time. There are some provisions for having a background task hosted in your app's own process, but even if you exercise those provisions, you cannot do anything UI-wise from a background task. Remember, you have to assume that your app is not running while this background task is executing. That does beg the question, what if I'm performing some calculations in this background task and I want to show those to the user the next time my app starts up? There is a provision for doing that. I'll show you, I'll address that in a few moments. But for now, let's focus on the background task itself. Now, in the background task, in the class that implements the iBackgroundTask interface, you will override a virtual method named run. That's that method I told you about that contains the code that the system will execute in the background every now and then. But it won't execute anything in the background for you until you register that background task. We'll do that over in our main app, perhaps the first time it starts up. We'll check to see if that background task is already registered by this Windows Store app, and if it's not, we'll use the background task API to register that task. It's important to make sure before you register a background task on behalf of your app that that background task is not already registered, because these background task registrations are persistent. If your app registers a background task the first time it's executed, that task will still be registered the next time the app executes and the next time after that. Now, on the Windows Phone, when you register a background task, we actually time it out after a couple of weeks just to make sure that an app that the user has installed on their phone but has forgotten about isn't needlessly consuming CPU resources. That is not the case in Windows 8. Once you register that background task, unless your app is uninstalled from that device, that background task remains registered. And if you just blindly re-register it every time your app starts, you're actually registering multiple background tasks. So, I'll show you the code for doing it. It's very simple. You check to see when your app starts up if a background task you want to execute is already registered. If the answer is yes, then you do nothing further. If the answer is no, then you use a WinRT API to register that background task. You can register as many background tasks as you want, but remember that you are limited in how much CPU time and sometimes network bandwidth you can use. It's also important, and I'll show you this in my first demo, to put a flag in the application's manifest indicating that it uses background tasks. Now, I'll tell you this. In working with these things, there are a couple of mistakes I've made that have cost me development time. When I wrote code, registering background tasks and all that, and then I started testing and debugging, and lo and behold, for some reason the background task wasn't executing for no apparent reason. One possibility, if you see that happen, is that you forgot to mark the app's manifest indicating that it does use background tasks. The other thing that will cause that to happen is, remember, you implement this background task class in a separate project in your Windows Store app solution. You must remember to add a reference to that project from the Windows Store app solution. Otherwise, all your code will work, the registration will succeed, but nothing will ever execute in the background. And it's hard to debug that when you set a breakpoint in the background task, but if the background task doesn't execute, what are you going to debug? In fact, when I do this next demo, this first demo, I'll have to remember to do those two steps there, otherwise it won't work very well. So if I forget, you help me remember, okay? Now, in terms of implementing the background task itself, remember, you add a new project to the solution, you add a class to that project, and in that class, you implement the iBackgroundTask interface. You override the virtual run method, as I've done in this slide, and that, again, is the method that will execute in the background each time the system decides to schedule your task for CPU time. Remember also that once you register a background task, it remains registered in theory forever unless you unregister it or unless the user uninstalls that app. This is the API that you use to find out what background tasks your app currently has registered. The background task registration class has a static property named allTasks. It is an IEnumerable. You can iterate over that IEnumerable and see each and every task that your application has registered. If you want to register a background task, and you have determined that it's not already registered, then this is the code that you write to do the registration. You begin by newing up an object of type background task builder. You give that task a name. It can be anything you want. That's the name that you'll use to identify it when you check to see if the task has already been registered the next time your app starts up. You also specify the task's entry point. This is the fully qualified type name of that iBackgroundTask class that you implemented over in the other project. Unfortunately, you can see that's just a string name. You'll probably get no indication if something's wrong if you misspell that, so you must make sure that that type name matches the type name that you used in the background tasks project. The next thing you do is you call setTrigger on the background task builder object. You only call this once. The trigger is what tells the operating system when to run your task in the background. Now, there are several different types of triggers. We're going to talk about those in this session this morning. What I'm doing here is using something called a system trigger time zone trigger. I'm asking the system to execute the run method in each of my registered background tasks, or for this registered background task, I should say, whenever the user changes the time zone on his or her computer. Now that may not be all that interesting, but I'm using that for demonstration purposes here because I'm going to do this same thing in my first demo. And in order to make the background task execute so we can see it do something interesting, I'm simply going to change the time zone on my computer. Once you've done that, you're ready to register the task. You do that by calling the register method on the background task builder. Now, we're going to do this in just a moment in Visual Studio. We're going to see if it actually works. After all, I could be making all of this up, right? For all you know, if I don't actually show you code. I could be making it up. Now, I'm not, but I'm going to prove it to you. Remember that once you've done the coding, there's still a little bit of work left to do. You have to go into the Windows Store Apps manifest and do some background task registration as well. Specifically, you need to go to the declarations page of the manifest, choose background tasks from available declarations, and then click that Add button so that the manifest for this Windows Store app indicates that this app does use background tasks. Now remember, an app can register multiple background tasks if it wants. If you are registering multiple background tasks, then you'll need to add an equal number of background task declarations to the manifest as I'm showing right here. You also have to specify the entry point. You see this down at the bottom in this form. This, again, is that fully qualified type name of the class that implements the iBackground task interface. It may seem a little redundant and a little bit silly that you have to specify that both in the manifest and in the API, in the Background Task Builder API, but it is what it is. You must do it in both places. If you forget to do it in one of those two, then your background task will not execute. If you choose to unregister a background task, there's an API for doing that as well. What you do is iterate through the background task that your app currently has registered until you find the task that you want to unregister. Then you simply call the unregister method on that task. And with that, let's see if we can build something to actually demonstrate this at work. How about that? Now, the reason I'm doing this demo live and not just showing you some canned code is because it is important to hit all the steps. And like I said, in the past when I've done this in real projects, when I've forgotten one of these steps, it just mysteriously hasn't worked. So I want you to see what this process looks like. It's not hard if you remember to do all the steps. So let's go into Visual Studio and let's write something. Wow. The new Bing Daily Image. Oh, that must be like under the polar ice cap. I thought I was looking at an X-ray or something like that. Oh, wow, what are they doing putting an X-ray on Bing? So let's go to Visual Studio and write a little bit of code here, folks. So I'm going to create a new Windows Store app project here. We'll just choose blank app as the template type. And let's see, let's give it a name. Let's call it Task Demo. How about that? Oops, there's already one of that name. I guess I've used that. How about B-Task Demo for Background Task Demo? Okay, looks like Visual Studio is a little bit happier with that. And we see here a Windows Store app project appear. So far, so good. Now, what we're going to do in this thing, of course, is register a background task and see if we can actually get this task to run. To do that, I now need to add a separate project to the solution. Let's go ahead and do that. So I'll right-click the solution, do an Add New Project, and it's important that you choose Windows Runtime Component as the project type. Now, you can call this anything you want. Let's call this Sample Task, like that. And I'm going to get rid of that class that's already in the project. We'll just add our own. And let's see here. So let's do an Add Class. This is the class in which I'm going to implement the iBackground task interface and override the run method. So let's give it a name. How about, I'll call it Time Zone Task like I did in the slides, since we are going to use a time zone trigger on this. Now, Time Zone Task, let's get a dot in there for .cs. And now here's a class in which we can implement iBackground task. So let's go ahead and do that. iBackground task, looks like we're going to need some help from Visual Studio here, maybe a little using statement. So I'll do a resolve, and then I should be able to right-click it and ask it to implement the interface for me. And there is only one method in that interface. It is the run method. So now I have a placeholder for the code that I want to execute in the background. Now let me caution you about this as well. There's another pothole here waiting to reach up and catch you. If I proceed right now, I implement the code in this run method, I go over, add a background task declaration to my Windows Store app project, and I register the task and all that, it will not run. The documentation doesn't make this incredibly clear, but the class that implements iBackgroundTask has to be public, and it has to be sealed. If you leave off that sealed keyword, guess what? The background task will never run. You'll get no exceptions, no error indications of any time. The runtime simply will not schedule the background task to execute. So, don't forget public sealed. I've forgotten that a time or two, and it will reach up and bite you, believe me. Now, the question is, what are we going to do in this background task? Well, we want to do something that's visible, but remember that a background task can't do anything with the UI, because it's highly likely that when this task runs, your app is not running. So what are we going to do? There are a limited number of things UI-wise that a background task can do. It can pop up a toast notification, for example. It can update the application's tile. So what I'm going to do is paste in a little bit of code to add something to the application's tile so that we can see some visible evidence that this task has run without even running it in the debugger. Now, to do that, I've actually got some sample code later in the session that I'm going to borrow from. And let's see here, right here. I'll borrow this code right here and paste it into the run method here. And I'll probably need a using statement or two. So we'll start with this one. What else do I need? It looks like I'll need a using statement for this one. Okay, and now Visual Studio seems to be happy. If you've never seen this kind of code before, this is pretty much boilerplate code for applying a badge to an application's tile. Badge can be a number from 1 to 99, or it can be one of 13 predefined glyphs that the operating system provides. You see the string over on the right-hand side that says new message. If this works, what this is going to do is add a little envelope icon in the lower right corner of my application's tile, similar to the one that the Mail app shows you when you have new mail waiting. So that'll give us some visible evidence that this thing has actually executed. So that should do it. Let's just make sure that I've done everything right. In this separate project, I added a class named TimeZoneTask that implements iBackgroundTask. I remembered to make sure that that's a public sealed class, and I overrode the run method, and I pasted in some code that's going to add a badge to the application's tile. Now, the other important thing not to forget, let's add a reference to this project to the Windows Store Apps project. So up here, I'll right-click, do an add reference, check sample task right here, and do an OK. And you can see that it's been added in there. Again, if you forget to do that step, everything will compile and seem to work just fine, but your background task will never be executed. Okay? Everyone with me so far on this? Okay. Let's go back and do a little bit of work in the Windows Store app. Remember, we need to register the task. We also need to add a declaration to the app's manifest indicating that we do use background tasks. So let's start with the manifest. Here in the Windows Store app, I'll open up the manifest and I'll go to the Declarations tab. Then I'll find Background Tasks, and I'll tell it that I'm going to be registering one background task in this app. Now, I love this UI because Visual Studio is telling you that right now you haven't provided enough information for this thing to build and run. Among other things, you have to specify what type of trigger you're going to be using. I'm going to be using a system trigger, so I'll check System Event. And down in this app settings part, you have to specify the fully qualified type name of the class that implements iBackgroundTask. Well, since I called that project Sample Task, the namespace name will be Sample Task, and the type name, the class name, is TimeZoneTask. So TimeZoneTask, like that. Now I'm going to need that again in a moment in the code that I write, so I'll paste it in there. I see the X's go away. It appears that Visual Studio is happy with this declaration that I've added to the manifest. Let's save that so that I don't lose it. Now, all that's left is to write a little bit of code. So let's close down the manifest here. Don't need app.xaml.cs. And let's see here. That we shouldn't need that anymore either. I do have unsaved changes there. Now let's go to mainpage.xaml here in our Windows Store app. So here's what I'm going to do. When this app starts up, I want to register this background task, but before I do that, I have to make sure it's not already registered. Otherwise, remember, I'll end up registering it a second time, and it will execute twice needlessly, using up some of my CPU quota. So let's do this. Let's go up here and declare a little string, which we'll use for our task name. I'll do a private const string, and let's call it name. And we'll give our background task a name that we can use to refer to it when we register it or when we check to see if it's already registered. We'll call it my task. How about that? Now, when the app starts up, first thing I want to know is this background task already registered? So what I'll do is this. Background task registration. Spell that right. And let's get a using statement in there so we can get some IntelliSense help. So let's do all tasks. And that returns an IEnumerable, remember. What I'll do is just quickly use a little bit of link to see if there's already a task of the name. I'll do a where x. How about this? We'll do x.value.name equals underscore name. And then I'll do a first or default. And what I'll do is declare a var there and assign that to task. So what's going to happen now, if I've done my job right, is when this app starts up, if the background task is already registered, that line of code is going to return non-null. If it returns null, that means the background task is not already registered. Therefore, I want to register it. So we'll say if task equals null, and then we'll do a little bit of work down here. So what do we need to do? Well, let's see here. Find the home key on here. Oh, and I see I misspelled that. That's why I'm getting the red squigglies. To make short work of this, let's go borrow some code from a slide we looked at a moment ago. And then I'll make some changes to it, but that should get us to the point that we can actually run this thing and test it and see if it's going to work. So let's grab this code right here. And let's paste it in. Var task. And why am I getting a null right here? It says, can I be applying to operands? What I need to do is task.value right there. That should satisfy Visual Studio. So then, let's check this code. I knew up a background task builder. I'm going to call this thing, what we want to do is call it this up here. So I'll just use underscore name. And then for the entry point, this is the fully qualified type name. Sample task is the namespace name. And I believe that I did call the class name inside time zone task. I did, so that should be sufficient. That should match what's over in the manifest. Let's just check to make sure. So declarations, the type name sample task.timezone task. Is that the same as I have right here? Sample task.timezone task. It is. Then I set a trigger. Every task has one and only one trigger. You cannot have multiple triggers. The purpose of the trigger, again, is this is how you tell the operating system when you want it to execute this task. And again, we'll be talking about all the other trigger types in just a few moments. It looks like I've done everything correctly. So I'm going to close the spaces up for neatness, and I should be registering the task. So I'm going to assume I've done everything correctly. We're going to build this thing. We're going to run it one time. We're going to look at the application tile. Should see that there's no badge there currently. Then I'm going to change the time zone on this computer. And when I go back to the start screen and look at the app's tile, I hope to see that little new message badge appear in the tile. If that doesn't happen, then we'll start tearing into it and debugging it to figure out what I did wrong. But as far as I know, I did everything correctly. So let's run it. Do a start debugging. Okay, that's encouraging. I didn't see any exceptions thrown or anything when I started up. That task should now be registered. Now let's pop over to the start screen. Here is the applications tile, which I didn't really need to click. I just wanted to make sure there's not currently a badge on there. If everything went as expected, there is now a background task registered. And even though our app is not running, and for all we know may never run again, the user may elect never to run it, if I change the time zone on my computer, that should cause that trigger to fire and should cause my background task to execute. So everyone cross your fingers. We're going to give it a try. So I'll go down here and let's see here. Go to adjust date and time. In a couple of days, I'll be flying home and I'll be going from this time zone to the Eastern time zone in the U.S. So let's just go ahead and make that change. And let's see, that'll be UTC -5 Eastern time, U.S. and Canada. I'll do an OK. The time on my computer now shows 3:30 a.m. I guess my family back home is asleep right now. And in theory, if we go back out here, in theory, we should have seen that little icon appear right here, and we did not. So either I've done something wrong or Windows 8 is being cantankerous. One thing I want to do just to be sure is do this. Let's change the time zone one more time just to be sure. Actually, it's possible too. Sometimes it doesn't appear in me. Oh, look at that! Yes! We just executed code in the background. I just wasn't patient enough. I needed to give Windows 8 a few seconds to roll that little icon up there. We just implemented a background task. We proved that Windows 8 executed it, even though our Windows Store app wasn't running. So you know what? If you don't see anything the rest of the day, I hope your day is now complete. Yes, sir. How much of my 1 second of CPU time did I just use? I really have no way of knowing. Probably just a very, very small fraction of it. I'm guessing milliseconds because it was 4 lines of code. There is not an API, unfortunately, for finding out how much quota you have remaining. That's a great question, too. You might think that there would be an API for saying, okay, how much do I have remaining? There's not an API for doing that. All you can do is just do your thing, be as efficient as possible, and know that if you do too much, if you exceed your quota, the system is going to basically not run your task again until it renews your quota. Okay? All right. Everything good so far? It wasn't that hard, right? Once you know all the steps. Yes, sir? Is it necessary for the user to run the app the first time? It is. In a Windows Store app, there is literally no way to provide installation code or anything like that that executes when the app is installed. The user does have to run the app at least one time so that you get the chance to execute that code that registers the background task. Yes, sir. Okay, now, so that's a good start. You've seen the steps involved. I'll show you more examples, but these examples, the next examples, I've already built because they're more complicated, and but I did want you to see the process that you go through. So, in that example, I used a very simple trigger. I used a time zone trigger, which is going to execute my background task if and when the time zone changes. I think you would agree that there aren't many apps that are going to need to do that. I used it again so I could easily cause the thing to execute. But what other trigger types are there? By the way, this is something, there is a background tasking API in Windows Phone. Some of you who are phone developers have probably used it. This API in WinRT is different than the one in the Windows Phone. It's actually quite a lot richer than the one in the Windows Phone. One of the most important things to know about in the WinRT background tasking API is the triggers. Now, there are several different types of triggers. Remember that every background task you register must have one and only one trigger associated with it, telling the system when to run it. Here are the different trigger types that Windows 8 supports. There are 5 basic trigger types: system, maintenance, timer, push notification, and control channel. For a non-lock screen app, you're only allowed to use system triggers and maintenance triggers. In fact, there are some system triggers that are restricted to lock screen apps. So what I want to do for now is focus, and for the next few minutes, is focus on non-lock screen apps. The generic things we can do with triggers in any Windows Store app. So that means for the moment we're going to be relegated to system triggers and maintenance triggers. Now, of the system triggers, these are the types that you can use in any Windows Store app. That is, even apps that haven't been integrated with the user's lock screen. For example, there's an Internet Available system trigger. Maybe you want to execute a background task every time the internet comes available. Maybe you're providing an offline strategy in your application. So as the user enters data, if you don't currently have an internet connection, you store it somewhere like in application data or perhaps even in the file system. But then you want to know the moment the internet becomes available so you can take that data that you've cached and you can upload it to a web service somewhere. But how are you going to do that if your application may not even be running at the moment the internet comes available? Well, you can build a background task that will do that upload for you, and you can assign it an Internet Available system trigger. So now, regardless of whether your app is running or not, if that connection comes available, you're woken up, you're notified, and you get a chance to shoot some data up. You can see that there are other system trigger types as well. Time zone change at the bottom is the one that I just used. One of the other interesting ones is the one called servicing complete. You've probably seen if you use Windows 8. Let's say you go to the Windows Store, you find an app you want to download and install, and so you do it. And then a few days later, you sit down in front of your PC, and you notice that there's a little badge on the Windows Store tile on the start screen indicating you that some updates are available. So you go to the store and you find out, lo and behold, there's a newer version of that application available, the one you downloaded just a few days ago. So you click a button or two, and the new version gets downloaded from the Windows Store and installed on your machine. So there may be some code you would like to execute when your app is updated. Maybe you're storing some client-side data in that app, and in version 2, you've changed the schema. So the moment the new version of your app is downloaded to a given user's machine, you want to execute some code so that you can change the schema of that data in preparation for version 2. That's what the servicing complete system trigger is for. It gives you the opportunity to register a background task that will only execute when a new version of your application is downloaded and installed on a user's machine. Now, there are a few other system trigger types, and I'm going to defer discussion of these until a little bit later, but these system trigger types can only be used by apps that do integrate with the lock screen. Again, that's the minority of Windows Store apps, not the majority. So here's an example of using a trigger other than that time zone change trigger. I'm newing up a background task builder, registering a background task. But the trigger that I'm assigning it is that servicing complete trigger. In other words, the one that allows my background task to execute if and when a new version of my app is downloaded and installed on this machine. Now, what a lot of you probably came to this session for was to learn how to write background tasks that execute periodically. How do you write code that wakes up, say, every 30 minutes and goes out and checks with a network service to check for flight delays or check for weather conditions or check for stock prices that you're watching or something like that? That's what the maintenance trigger is for. This is different from a system trigger. It's a completely different trigger type, but it is available to non-lock screen apps. If you want to execute code periodically in the background, then you do what I'm doing here. You code up a background task as usual, overriding that run method. Then, when you call setTrigger, you pass in a maintenance trigger instance. And when you new up the maintenance trigger, you get a chance to pass in two pieces of information. The first one is a value indicating how often, that is, in minutes, this task should run. This will compile with any number, but at runtime, if you specify a number less than 15 minutes, the app will throw an exception when you new up that maintenance trigger. Under no circumstances, with the maintenance trigger or anything else, does Windows 8 allow you to execute code in the background more often than every 15 minutes. So 15 minutes is the minimum. The second parameter is a Boolean. If you pass in false, this means you want to execute it every 15 minutes at recurring intervals. If you only wanted this background task to execute one time 15 minutes out, then you would pass in true. But again, passing in false means that this is a recurring task roughly every 15 minutes. You'll be awakened and you'll be given the opportunity to execute some code. So far, so good. I said a moment ago that this WinRT background tasking API is richer than the Windows Phone background tasking API. And one reason it's richer is that WinRT provides all these cool trigger types. Another reason it's richer is that it also provides something called conditions, which is something, once I got used to these in WinRT, I missed them in Windows Phone when I write background tasks in Windows Phone. By the way, a lot of us hoped that when they ported a part of WinRT from Windows 8 over to Windows Phone 8, that the part they ported would include Windows 8's background tasking API. They did not do that. So the background tasking API in Windows Phone 8 is the same as it was in Windows Phone 7. And while there are similarities to Windows 8's WinRT background tasking API, there are lots and lots of API differences as well. Conditions allow you to add conditions that have to be true before the system executes your background task. So let's say maybe you're using a maintenance trigger to execute some code in the background every 15 minutes. But in your background task, you need a network connection because you're going to make a call out to a web service somewhere. And if there's not a network connection available at the moment, you don't even need to run the task because there's nothing useful you can do. What you can do then is add a condition to that background task that tells the system to wake you up and to run you when the trigger fires, but if and only if the condition that you've specified, an internet available condition, is true. Now, there are several different conditions that are supported in WinRT. I've listed them here. You can see internet available, which is probably the one that is used the most often. If for some reason you only want to run the task if there's not currently a network connection available, then you could use, for example, the internet not available condition. Adding a condition is done by calling the add condition method on the background task builder object. Remember, you can only call set trigger once for a given task because a task can only have one trigger associated with it. But a task can have as many conditions as you want associated with it. So you can call add condition 0 times, 1 time, or as many times as you want. And one reason I like this is if I want to do the same thing on Windows Phone, since its background tasking API doesn't support conditions, I have to have the system wake me up, then check myself to see if there's a network connection available, and if not, just go back to sleep. Well, on a Windows Phone, I've used up a few milliseconds of my allotment of CPU time. With this, in WinRT, if that connection isn't even available, then I consume 0 CPU time because the system doesn't even wake me up to begin with. Now, a few moments ago, I posed a question that I told you I would answer. In your background task, you have very, very limited access to UI. You've seen that you can update an app's tile by putting a badge on it. And remember, a badge can be a glyph or a number from 1 to 99. You can do more extensive tile updates, changing the background of the tile and things like that. And you can pop up toast to let the user know, for example, that their flight is delayed. If the user then taps that toast, it'll activate the application that's associated with that background task. Other than that, there's not much you can do in terms of UI. So what if in your background task, you're doing some work, maybe it's computational work, maybe it's something else, but the next time your app starts up, you'd like to have the results of those computations available so that you can display them to the user. For that, you use application data. Now, application data is a whole other subject in Windows 8. Some of you have probably dealt with it, some of you have not. Application data is essentially a set of private data stores, private to each Windows Store app, where data can be written and persisted. So in a Windows Store app, for example, if I accepted a bunch of input from the user, maybe the user has filled out a form, and I wanted to persist that data, one way to do it is to write it to one of the application data stores. The key here is that a background task is associated with one and only one Windows Store app, the one that registered it. You have access to application data from a background task. So in your background task, if you've done some computational work that you want to make available to the app itself, you write it to application data. Then, the next time your app starts up, you check application data to see if the data is there. If it is, then you read it out of application data. So, the mechanism that we use to pass data from a background task over to an application when it runs is application data. There is no direct pipeline, no IPC mechanism like a named pipe that would connect the two. And one reason for that is, remember, it may never happen that your background task and the app are running at the same time. Therefore, they use this indirect mechanism, application data, if they want to pass data back and forth. And by the way, when I say back and forth, I mean that. Not only can a background task write to application data so that it can be read by the associated application, but the app can write data to application data too, which can then be read by the background task. So, let's look at another example, one that's a little bit more sophisticated here, and see how well this works. So let me show you this example. I'm going to open it up. And by the way, let me pause for a moment and show you this. There are two more demos I'm going to show you here in this session, which I have pre-built. It occurred to me you might like the source code for them, the Visual Studio solution, so you can play with them yourself. So I uploaded them to SkyDrive this morning, and that is the URL. The URL is case sensitive, at least the letters out at the end. If you go there, it's a zip file containing two Visual Studio solutions, containing the sample I'm about to show you, and the one I'll show you a little bit later in the session. I'll leave that up there just a moment so that you can download that. Nice, short URL. And remember that those last 6 characters are case sensitive. Big X, little r, big T, number 1, big Q, little f. Okay? And I'll put that back up at the very end of the session in case you didn't get a chance to get it. So let's go open this thing up. So I'm going to go into my samples folder, Windows 8, background task demos, and I want to open a project called Periodic Task Demo. And before we run it, I want to walk you through the code so you can see what it does. And because I haven't said anything yet about how to debug these background tasks, I'm going to show you how to do that as well. So Periodic Task Demo is my Windows Store app. What I'm doing in this one is this. Each time this app runs, it does this. It checks to see first, do we currently have internet access? And it warns me if we do not. Then it uses WinRT's location API to find out where on the surface of the planet Earth I currently am. With all the travel I've been doing lately, sometimes I've been waking up in the morning wondering where on the surface of the planet Earth I am. Once I've found out where I am, then I new up an HTTP client object, and I make a call out to a U.S. government web service that provides free weather condition data. Now, I've done a little bit of experimenting with this. Apparently, the U.S. government believes the U.S. is the only country in the world. We may or may not get back real weather data for here in Belgium. If you run this with a U.S. location, it actually works. I could hard code in a location, but we're going to see if this works when I go out to the location API and get our current location. What I'm getting back from that web service is a big glob of XML with all sorts of information about the current conditions at that particular locale. So next, my challenge is to parse it to get the data that I care about. And that's what I'm doing right down here with these few lines. I'm using a little bit of link to go in and find the city and state that corresponds to the latitude and longitude that I passed into this web service, and to also get the current temperature in degrees Fahrenheit. Don't be alarmed if we see a very large number, because it's not Celsius, it's Fahrenheit. And then I display all of that to the user. Now, this is the Windows Store app itself, remember, not a background task. So, and if any of this fails, if I don't get back valid data from the government web service or anything else. What we're going to end up seeing is a message that says weather data unavailable. I hope not to see that, but we might indeed see it. But then I'm going to go a little further. I'm going to bring background tasks into the equation. I'm going to check and find out if a background task named periodic task is already registered. You can see me making that call here. If it's not, then I'm going to register it. And this code should look pretty familiar by now. It's very similar to the code that I used in our first project. I knew up a background task builder object, give the task a name, provide a fully qualified type name, and look, I'm using a maintenance trigger. I'm asking the system to execute my task in the background every 15 minutes. And I'm adding a condition because I am going to be using the internet from the background task. I'm telling the system furthermore, only execute this at each 15-minute interval if there's currently an internet connection available, and then I register that task. So when the app starts up, it goes out and attempts to get my current location and the current weather conditions there to show them to me in the UI, but it also registers a background task if a task isn't already registered to do essentially the same thing. Now let me show you what the background task looks like. It's in the separate project named Periodic Task. Periodic Task is the class name. It's public and it's sealed. Remember, that's a requirement. And it implements the iBackground Task interface. That's a requirement too. What do I do in the run method? Well, essentially the same thing that I did over in the app itself. I use the location API to find out where I am. I make a call out over the internet to find out what the current conditions are there. Then I use a little link to extract the data that I want. And now I can't just show something to the user in a XAML UI here because, remember, this is a background task. But what I can do is update my application's tile with a badge, a glyph, or a number 1 to 99. So what I'm going to do is, assuming the temperature is somewhere between 1 and 99, I'm going to add a numeric badge to my application's tile showing what that current temperature is. If something goes wrong during this, if any of my code throws an exception, you'll note that I've got it all in a try-catch block, then in the catch, what I'm going to do is display a glyph badge on my tile, an error glyph, which it looks like a little circle with an X in it. So regardless of whether I'm actually able to get the data from the U.S. government web service or not, we should see something happen on the application's tile. That'll either be an error glyph or a number from 1 to 99 indicating the current temperature at our current location. By the way, let me show you something else. You may notice that there are a couple of extra lines of code in here that I didn't use in the previous demo and that didn't appear in the Windows Store app. If you've never dealt with deferrals before in Windows Store apps, this is one of the most important things that you will ever learn about. There are times when the system calls you and expects you to do something, and once you return from the callback method you provided, unless otherwise specified, the system assumes you've finished doing whatever it asked you to do. The problem is this awesome new async and await pattern that's used throughout WinRT. You'll notice this is an asynchronous call, but I'm using C#5's new await keyword to await the call. Now, await is not blocking this thread. What await is actually doing, it's letting the compiler generate a bunch of code that actually returns from this method, but not before registering for a callback for an event that fires when the asynchronous request is complete. The whole purpose of the async await pattern in WinRT and the C#5 is to make asynchronous coding really easy by making it look almost synchronous. But when you realize that what it's actually doing is having the compiler emit code that returns from this method, you realize, wait a minute, here's an example of a method the system is calling, and when I return from it, it assumes I'm done. So if I didn't do this, I would never get past here in this background task. Since I am using await in this run method, I ask the system for a deferral. This does not give me additional resource quota, doesn't give me additional CPU time, anything like that. It simply says to the system, I'm going to be returning from this run method one or more times because I'm using the await keyword. Don't assume each time I return that I'm finished executing code in the background. I'll tell you when I've finished. And the way I tell the system that I'm done is by calling complete on the deferral. Now, this is one of many cases in Windows 8 where these deferrals are key. Another classic example is an on-suspending event handler. When you build a Windows Store app, since the app is suspended when it's not visible to the user, a suspending event fires just before you're suspended, giving you the opportunity to save any state that you will need to restore if, while the app is suspended, the operating system decides to terminate it as well. By default, when you return from a suspending event handler, the system assumes you're done. You've saved everything that you need to save. But if you're going to use the await keyword in the suspending event handler, you must grab a deferral first, giving you the opportunity to return from that suspending event handler as many times as you want without implying to the system that you're finished. Then you call complete on the deferral at the end. So these deferrals, they seem to be mysterious. I get asked a lot of questions about them. They're nothing more than a mechanism to let the system know we're about to return from this method, but we're not done. I'll tell you when we're done. Okay, I hope all of that makes sense because we're going to run this thing right now. So let's run this app. I'll do a start debugging. In fact, let's do this. Let's see. I don't know if this app is already installed on this machine. I don't think so. Looks like it's not. That's good. So we will run it. And wow, what am I getting here? Build stopped because of an internal failure. Build was canceled, failed to successfully launch or connect to a child MS-build.exe process. Wow, don't you love that? Let's try cleaning the solution, see if that helps a little bit. And also do a rebuild. Wow. Okay, we're getting something. Well, the best thing to do at this point, first, let me check to see. Expectedly, I'm just getting internal failures. Best thing to do at this point is give Visual Studio a coffee break. Then go back and try it again. And just to be safe, I'll do a clean solution here. And let's see if we have better luck this time. Beats me. Now, Windows 8, since it sees that this app is calling the location API, is asking for permission to use my current location. It's going out and getting that location now, probably by now making the call out to that government web service. And I hope we see an actual temperature. Worst case is we should see that data not available here in a moment. And gee, it usually doesn't take nearly this long. I actually didn't build in a timeout provision here. Perhaps I should have done that, but we'll give it a moment or two here. And it may not be a bad time to make sure that I still have an internet connection. Let's do this. Let's pop over to the desktop real quick. Make sure I still, obviously I have an internet connection, so let's go back to this app. And let's just give it a moment here. Well, weather data unavailable. So I think we could set a breakpoint and see, but I think it probably retrieved the location fine, and then when it called out to that U.S. government web service, which isn't aware that there are other countries in this world, we got back bogus data or no data at all. So that's still fine for our purposes. At least the call went out. Now, let's do this. Let's shut this thing down, and let's go look at the tile that was created on the start screen. Periodic task demo right here. And you'll notice that there's no glyph in there because in the app itself, I'm not attempting to put a badge on the tile. I'm only doing that in the background task. Now, presumably, that background task is now registered, and you recall that I used a maintenance trigger to ask that it execute every 15 minutes. So what we're going to do now is stare at the screen for about 15 minutes and see if something appears on that tile. Does that sound like a good use of our time, given we have 15 minutes left? Should we just stare at the screen for 15 minutes? Wouldn't it be nice if there was some way to debug a background task, to actually force it to execute, so maybe you could put a breakpoint in it? Wouldn't that be useful here? Well, would you believe in the early days, some of the early builds of Windows Phone 7, in the early days of its background tasking API, and on a Windows Phone, you can't run background tasks every 15 minutes. The minimum is 30 minutes. In the early days of Windows Phone, there was no way to force a background task to run. So literally, the way we debugged it was we'd run the code, come back 30 minutes later to see if something had happened. Fortunately, that's no longer true in Windows Phone, and there is an easy way to see your background task execute in the debugger. Let me show you what that is. Let's go back to Visual Studio here. And let's see here. Are we running? No, that's fine. I'm going to go into my background task itself. And let's just see what happens. We'll step through the code and see if we're getting the location and all that. So I'm going to put a breakpoint there. And all we now need is to somehow force this background task to run so we can see it execute. So watch this. If you go up to, okay, my toolbar has gone. Let's go look under View. Oh. I have to have this thing running in the debugger. At least it came back quickly that time. Here, look what shows up here. Periodic task. That's the class name of my background task. So it shows up in the debugger while the app is running in the debugger. And if I had registered multiple background tasks here, they would all show up. In fact, this is one of the clues that you can use to know if you've done something wrong. If I had, for example, forgotten to add a reference to the background tasks project to my main project, that wouldn't even appear in the drop-down list. So it looks like I've done everything right. Let's select it and see if we can force a background task to run. Look at that. We're now executing our background task. We didn't have to wait 15 minutes. Aren't you relieved? I don't know what I would have done for 15 minutes. Maybe put on a jet video or danced or something like that. So let's step through here and let's see if we can see what's going wrong. See if the culprit is that U.S. Weather Service. So just made the call out. I did an F10. At least I think I did. Actually, I may not have. There I did the F10. Now we're calling out to find out where we currently are. And, okay. Interesting. It went all the way back up there. That doesn't make sense. Let's try that again. Maybe I'm pressing the wrong key. Oh, there we go. Okay. Oh, we re-entered the method. That's what was happening there. Now, what is the latitude and longitude we got back? We got back a latitude and a longitude. So I'm betting that we're not going to get anything out of this government weather service. Let's see. Okay. All right, we're re-entering it here. And let's see here. Let's see what happens. I wonder if I'm going to throw an exception. Yep, so the XML I got back from the service was not what I expected, so the problem is that U.S. government web service. What I'm going to do now is do an F5 to allow this thing to continue to run. That should execute the code in my catch block here that adds a badge to the tile. And if I now pop out to the start screen, let's just stop debugging here. If I now pop out to the start screen, right here in Periodic Task Demo, we should see a little error glyph come up in a moment. Let's see. Sometimes you have to kickstart it just a little bit, so we'll do a manual run. And there we go. There's the error glyph from the background task indicating that something went wrong. So I apologize that I didn't have the foresight to realize that a U.S. government weather service may not give me weather data for Europe, but everything else that you saw here is important stuff to know about. You've now seen a maintenance trigger used to execute code periodically in the background because it is set to execute every 15 minutes on the condition that the internet is available. That should update every 15 minutes. And if I can find a weather service that actually provides worldwide weather data, I'll incorporate it in here and post a revised version of those samples for you. So are you with me so far on this? Has everything that I've said made sense? All right. Well, there's still a little bit to talk about, so let's go back to the slides here and cover those and then get to one last demo. So the periodic task is simple to do once you know about the maintenance trigger. What we haven't talked about yet are the special things that lock screen apps can do. Now, do you know what a lock screen app is? Let's do this. If you don't know what a lock screen app is, I'm going to lock my screen here. I assume the projector's still going to work. Yeah, this is the lock screen in Windows 8. And you see a couple of little badges right down here showing the strength of my Wi-Fi connection, showing that I have full battery power and I'm plugged into AC power as well. The user can go into the settings on their Windows 8 device, and they can add additional apps to the lock screen. Up to 7 apps can live on the lock screen. What that means is those 7 apps have the opportunity to add little icons, badges of their own to the lock screen. So if you were building an app that warned the user of severe weather, you might want that to be a lock screen app so that when you detect, you wake up every 15 minutes, you find out there's a tornado coming. Do you have tornadoes in Europe? You know, last time I was here in Antwerp 2 years ago for this conference, a tornado hit my neighborhood back home. It was actually a fairly, as tornadoes go, it was a fairly weak one, but did about $30,000 worth of damage to my house. It did millions of dollars worth of damage in the neighborhood. I got very lucky. So I'm almost afraid to call back home and see how the weather is. Anyway, if you were building a severe weather warning app, you might want to give it the option of going on the lock screen so that it could show something if there's a tornado approaching you. Maybe an icon showing someone running really fast or something like that. Now let's log back in here and get back to the slides. So, remember that a lock screen app is afforded a few things that a non-lock screen app is not. Here again, it shows some of those icons at the bottom. Not only can up to 7 apps be added to the lock screen, and each of those 7 can display badges on the lock screen, one of those apps, only the one designated by the user, can actually update the text on the lock screen. The text that here says, "Make Awesome Apps Build Conference." Now, there are a couple things you have to do to make your app lock screen capable, to make it even show up in the list of available apps that a user can install on the lock screen. You go into the manifest and you make the changes I'm shown here. The key one is the lock screen notifications dropdown, which defaults to not set. If your lock screen app is capable of displaying badges, that is those little icons or numbers in the lower left corner, then you select badge. If you also want to have the option of changing the text on the lock screen, assuming the user designates you as the one app that's allowed to do that, then you need to set badge and tile text as well. Now, you cannot force your way onto the lock screen. There's no way to do it. Part of the philosophy behind the design of Windows 8 is that the user is in control of everything. So you may be a lock screen capable app, but that doesn't mean that you're going to have access to the lock screen. The user has to physically go over to the settings screen and add you. You can programmatically find out if you have access to the lock screen by calling the get access status method of the background execution manager class. And there's a complementary method named request access async. If you find that you're not currently installed on the lock screen, this is something you typically do the first time your app runs, then you can call request access async. That will prompt the user saying, this app would like to live on your lock screen. Will you allow that to happen? If the user answers yes, then you will be installed on the lock screen. By the way, the verbiage that the operating system uses in the prompt doesn't actually mention the lock screen. Have you ever downloaded and installed a Windows Store app and been prompted with something like, this app wants to execute code in the background? What that's really saying is it wants to use the lock screen. Now here's the cool thing. You're not allowed to annoy users in Windows 8. You can call request access async one time in the lifetime of this app. One time and one time only. If you call it a second time, it doesn't throw an exception, but Windows 8 will never prompt that user again. Unless your app is uninstalled and reinstalled, you can only prompt that user one time to bug them to add you to the lock screen. So here's some code for checking to see if you have lock screen access. And here's some code that you can use if you find you don't currently have access to the lock screen to request that access, to prompt the user, if they haven't been prompted already, to allow you to be added to the lock screen. Now, The nice thing about being a lock screen app is that you are afforded a higher quality of service. You get more CPU time. Remember, 2 seconds every 15 minutes rather than 1 second every 2 hours than a non-lock screen app. If you're running on battery power, you have access to several times more network bandwidth. You also have access to new trigger types like the time trigger, which is similar to a maintenance trigger, but is only available to lock screen apps. Now, I'm not going to talk more about them here, but there's also a control channel trigger. If you were building a Skype app or something like that, for example, you might want to be awakened anytime a message comes in, a call comes in. If the user adds you to the lock screen, then you can use a control channel trigger to get that very high level of quality of service, but it's not available to non-lock screen apps. Once you are on the lock screen, when your background task executes, if you want to update the badge for your app on the lock screen, you do it the exact same way you update the badge on your primary tile. In fact, you may recall this is the code that I cut and pasted earlier in that first demo that I did to update my application's tile. So to update the lock screen, you just treat the lock screen if it were your application's tile. If you want to update the text on the lock screen as well, assuming the user has not only added you to the lock screen, but designated you as the one app that's allowed to change text on the lock screen, then you do that this way. You, again, treat the lock screen as a tile. This is the exact same code that we use to update text on an application's tile. Now, this is good, we have 5 minutes left. So let me show you the other project that's in the zip file whose URL I gave you earlier. This one is very similar to the one you saw earlier, to the periodic task demo. It does ask to be awakened every 15 minutes. It goes out and gets our current location, calls out to a web service to get the current temperature at that location. But not only does it show the current temperature on its own tile, it also shows the current temperature on the lock screen, assuming, of course, the user has allowed us to be added to the lock screen. So let's run it. And because I should be detecting first time it's run that we're not on the lock screen, it should prompt me. Well, I was not prompted, and I'm surprised by that. Oh, wait a minute. I bet I already had this thing installed. Let's do this. I'll bet I already had it installed. So let's do this. Lock screen, well, that's where it just got installed. Let's uninstall it. Okay, now let's run it again. Can I use my location? Yes. There we are. There's the prompt. Let lock screen demo run in the background. What Windows 8 is really saying here, and it is the OS that's displaying this prompt in response to my call to request access async, what it's really saying is, will you allow this app to be added to the lock screen? If we can just close this thing down. If we go out to the lock screen, we may or may not actually see anything there right now. Sometimes it takes a few minutes for it to show up. But we'll do this. I'm going to do a Control-Alt-Delete. Get out to the lock screen, make sure the projector's still working. We don't see it there. But in this case, well, we should be able to force it with the debugger, right? Let's try that since we have a couple of minutes left. Let's see if we can force it and actually see that thing appear on the lock screen. So back to Visual Studio again. I'll do the F5. And by the way, I won't have time to go through the code. It's very similar to the code in the demo I showed earlier, but you can download the code and look at it yourself. I'm using a time trigger here rather than a maintenance trigger. And remember, time trigger is only available to lock screen apps. So let's see here. Let me go back to Visual Studio. And I should see my background task here, and I do. So that should have forced it to execute. If I now shut this thing down and close down Visual Studio and go back to the lock screen, this would just make it a perfect morning. Look at that. There's my lock screen apps badge over in the middle. The little lightning bolt is my icon identifying the app, and the X says, well, something went wrong because of that silly U.S. government web service. So folks, that is background tasking in Windows 8. Let me put again that URL up here so you can download the samples if you want. And Let me just, with that, thank you for attending and hope you have a great rest of the day. Thank you.